Okay, question 4 is about calculating relative atomic mass, and then it goes on to look at time of flight mass spectrometer. So the first question is using the table, using the data in the table, calculate the relative atomic mass of titanium in the sample, give your answer to one decimal place, and this is worth 2 marks. So this should be fairly straightforward. And what you need to do is find the MZ value. So the first one's 46. Multiply that by the percentage that you've got, percentage abundance, and then add that to the next one, 47 multiplied by 7.8. Add 48 times 74.6. Add 49 times 8.5. And then divide by 100 because it's a percentage, so I should have 100%. I would always check this in my calculator. So I do the sum on the top line first, and if I do that, I get 4,782.5. Divide by 100, that gets me an answer of 47.825. And it gives you a clue in the question. Sorry, it says give your answer to one decimal place. So I need to round that to one decimal place, so I get 47.8. So the mark scheme for this would say I get 1 mark for that sum, and I get 1 mark for the answer to one decimal place. Okay, moving on. Write an equation including state symbols to show how an atom of titanium is ionized by electron impact, and give the MZ value of the ion that would reach the detector first. Okay, so first things first, the equation. So an atom of titanium. Let me just change my pen colour. So titanium, including state symbols, the sample's gaseous, and it forms a titanium positive 1 ion, and it gets an electron, and the electron doesn't have any state symbols. So that would get me 1 mark, one of those 2 marks. And then the second part of the question says, and give the MZ value of the ion that would reach the detector first. So the one with the smallest mass is going to reach the detector first. So the one with the smallest MZ values, which is going to be 46, is going to reach the detector first. So it's that one. I don't need to give anything else other than the MZ value, so I just need to put 46 to get that mark there. Really easy, but just check the question what it is that it has actually asked you to do. Okay, moving on. So 4.3, calculate the mass in kilograms of one atom of titanium-49, and you get the Avogadro constant 6.022 times 10 to the power 20 times 10 to the power 23. Okay, so to do this, I need to know the molar mass of titanium-49. So that is 49 grams, means that I have 1 mole, or the same number of particles as Avogadro's constant there. So to find out the mass of one atom, I need to take that 49 grams and divide by 6.022 times 10 to the power 23. That gets me 8.1368 times 10 to the negative 23. That's in grams. The question's asked us to calculate this in kilograms, so I need to divide that by 1,000, and then I get 8.137. I'm just going to round it to 1.837 times 10 to the negative 26 kilograms. Okay, with this kind of question, you just need to check the size of your answer and just think to yourself, does that look about right for the mass of an atom? And it should be really tiny number. If you've got a massive number there, what you've probably done is got this calculation the wrong way, and you just need to double check that bit. So yeah, 1 mark for that. That's quite a tough mark to get, but very manageable. Okay, moving on. The next part is 3 marks, and for this kind of question, they do like asking this kind of question, but what you've got to think to yourself is, right, well, what can I do? It's worth 3 marks, but also just think to yourself, it's 3 marks out of 105, and it's an A-star style question. So if you can do it, fantastic. If you're struggling with it, move on, come back to it and do it at the end. Okay, So you get an equation. So the time of flight mass spectrometer, the time of flight t of an ion is shown by the equation t equals distance multiplied by the square root of mass over 2e. Okay, so that's come from a combination of the kinetic energy equation. Kinetic energy is equal to half mv squared, and the velocity distance time equation. So velocity is equal to distance over time. Okay, so v equals d over t. Okay, anyway, moving on. So in this equation, d is the length of the flight tube, m is the mass in kilograms of an ion, and E is kinetic energy of the ions. In this spectrometer, the kinetic energy of an ion in the flight tube is 1.013 times 10 to the negative 13 joules. The time of flight of titanium-49 is 9.816 times 10 to the minus 7. Calculate the time of flight of the titanium-47 positive ion. Give your answer to the appropriate number of significant figures. Okay, and so this is worth 3 marks.